So this image has ended up here with a diverging lens, and this image ended up over here and upside down. Now there's another key difference. So this was upside down. We call that an inverted image. It ended up bigger, so we would call that magnified. And we said that if we put a piece of paper here, because all of these rays are actually traveling over to here, the image would actually show up on a piece of paper. So that is a real image. On the other hand, over here, we had to trace these rays back and said, what if there were no lens? It would look like they came from here. So that is not actually, there's no real rays there except for the center. This ray going through the center actually passed through there. But the other two, the blue one, which was the one parallel to the optical axis, and the pink one, which was the one going for the focal point, both of those missed. And since it missed, what we have is this image here is a virtual image, because they are not actually, the rays are not all coming there. So you have a virtual image. In terms of being inverted or not, you can see it's not, it is upright. And then in terms of magnification, you can see that this image became smaller compared to that one. So you can call that a shrunken or demagnified or something to that effect image. Okay, so those are the differences. We can put a little bit of numbers to these sorts of things. So if we talk about the magnification m, then we just use that basically as sort of a ratio of our image size to our object size. Then we can basically summarize whether it's inverted, magnified, upright, or shrunken, all by talking about m. So when it's inverted, I will get the fact that it's less than 0, because basically a positive height became sort of a negative height. So I think about that as negative magnification. That's how I flip the image. Okay, so that's where you get inverted from. Otherwise, if m is greater than 0, then you got you have an upright image. And if you take the absolute value of m and you get that that's less than 1, then it's been made smaller. Whether it's upright or inverted doesn't matter anymore for the purpose of talking about what happened to the image getting smaller or bigger. A shrunken one will have m less than 1, or absolute value of m less than 1. And if m is greater than 1, then it's magnified or enlarged, etc. So that summarizes how to use these 3 special rays to find out where the image is, how to assess what the magnification has been, at least loosely, in terms of whether you've got an upright or inverted image and a larger or a smaller one. And lastly, it addresses what's going on with real or virtual images.